Hello, class. Today I'd like to talk to you about relative humidity. Okay, so here we have 3 glasses of water. The large container represents warm air, the middle one cool air, and the small one very cold air. All right, why the difference in sizes? Because these glasses, which represent air, they're also showing you their ability to hold water. Warm air can hold more water than cold air because when air is warm, there's more space between the molecules, more space to fit water. And that's why the most humid, muggy, miserable days are generally during very hot summer days. Okay, so let's just take a second to do this. I am going to fill up this container about halfway with water, all right? So when we say relative humidity, that means compared to other things. So the warm air right now has a relative humidity of 50% because it's halfway filled with water. And now our cool air, I'm going to fill up the cool air to 50%. All right, we're just going to talk about those for 2 seconds. So, all right, both of these are at 50% relative humidity, but which one has more water? The warm air, right? Okay, so even though they're both at 50% capacity, 50% relative humidity, the warm air has more water. Now let's take a look at the very cold air. Suppose I were to fill up this glass all the way. What percentage would that be, relative humidity, if it's all the way up? 100%, very good, all right? However, at 100%, the very cold air has much less water than the warm air, which is only at 50%. Okay, now how do we determine relative humidity? We determine relative humidity by using an instrument called a psychrometer. Okay, so this is how it works. We've got 2 thermometers. One is dry, and one actually has a wet cloth around it. So what's going on with the wet cloth is this. Since water is evaporating, and we know it takes energy to evaporate water, the water is taking energy away from this thermometer, and the temperature should be lower. So let's take a look. Okay, so let's look at the dry one first. The dry one has a reading of 76 degrees, and the wet one has a reading of 64 degrees. So that means that evaporation is taking place. So that means that the air must be able to hold some moisture because it's taking moisture away. So the lower the temperature of this one, the drier the air is going to be. And that's today. Right now it is about 4 o'clock on this Monday, and I'm in my apartment. And I'm gonna go across the street and get a reading from the park, because when you're in the park, you're around a lot more vegetation, a lot more trees and stuff. So I wanna go see if there's gonna be a big difference. So let's remember that, 76 and 64. I'm gonna write that down for later. Okay, so inside apartment. Okay, the dry is 76 degrees Fahrenheit, and the wet is 64 degrees Fahrenheit. There's a part of your reference tables that helps you figure out what the relative humidity is based on these numbers, but we're not gonna do that now. Okay, so that's video number 1. Okay, off to the park.